So I wanted to talk about this kind of random video, but um, just an observation about, and this is a little bit of history, but there's so much to talk about. I don't know what we're going to get to. What I want to talk to is about um, managing or controlling um, a Linux distribution. This could apply outside of the Linux OS. Certainly, a lot of the concepts do. And I think it'd probably be unfair not to talk about those things. This goes back to, sorry about that. This goes back to a prior blog where I was talking about some of the complexities that distribution makers are having right now with just the sheer number of software packages that they have to have under their control with regards to how they are distributed and patched over time for a version of a particular distribution. So let's talk just a little bit about that and what that means. Because for some of you, you may be already not really thinking inside of the box that I'm about to talk about already. Okay, so the idea is that from a a versioning perspective when it comes to the operating system, for example, as a world or as a realm that we can describe. If I say what a particular version, vendor, distribution, and version that I'm running, you should automatically have an idea of the supported packages of that particular Linux distribution. So if I were to say I am on Red Hat Enterprise Linux 9, then if that was the only information that someone gave to me, then I probably still have a rough idea of what version levels of packages of software are installed on the host for pretty common things. Now, you always have the ability, no matter what operating system that you're running, to run software elements outside of what the operating system provides through their package delivery. Okay. So you always have the ability, I mean, it's computers, right? So I could write my own code, or, I could use a package from some third party resource or commercial or what have you, right? Uh, and so I might not be, for example, a very popular package inside of Linux might be OpenSSH. And you say, well, that's, for Red Hat Enterprise Linux 9, I know that that's running at this particular version. And you kind of know what to expect with that. You say, well, what problems were in that version? And of course, as security problems come up, what happens is that particular distribution, because they manage that package at that version level, never going higher than that version level, they apply patches, they backport patches into what they would call their stable version base that's associated with their overall version of their distribution. So Enterprise Linux 9 may come with a version of OpenSSH, and that version, talking about the major and minor numbers, don't change, but there might be a P number, the patch number, that does increment over time, and that's to reflect high order fixes, mostly security related, that are backported into the version level that is delivered by that particular distribution. So, in other words, it's, from a pure developer perspective who's always thinking you got to run the latest version of my code, that's not how this works. Instead, you say, we are going to adhere to the base elements of a particular version of your software package, and then we'll backport in security fixes to that base version of software, the code itself, instead of forcing people forward. And you say, well, why don't you just push people forward? And what I just said, by the way, just to make things clearer, we're talking to tens of thousands of packages, okay, that have to be managed by. So a distribution manufacturer, be it Red Hat or whoever, is basically saying these are the base level packages that we support, and they're backporting security fixes into those as, things are reported, possibly some bug fixes, right? So serious matters. So the product doesn't work. I mean, they're probably gonna backport, fixes in. But most of the time, things have been well tested, so they know that it works. But if it doesn't work, they'll fix those things. If if it's a very serious problem, they'll fix those things. And then if mostly what you're going to see are going to be what we call security fixes. So as people figure out ways to hack or whatever the system, they'll put in those mitigations, for those problems into the version of software. And so what I would call this is a traditional enterprise managed distribution of Linux. Okay. But what's the problem? We mentioned it just a few minutes ago. There's tens of thousands of programs, and the list keeps getting bigger and bigger every day. I mean, wouldn't it be great, if we said web server and everyone said, well, Apache? But we know that it could be a number of different packages. One of the big ones that I think people would argue, they say, don't run Apache, run Nginx, right? So, you're right, so you kind of get the idea. And you say, well, gosh, there's just not that many web servers. You wouldn't believe the number of them that are out there. Okay, so, and we've seen more, as people start running basic web servers out of, certain development contexts like, um, whether it be Node.js, NPM, that kind of stuff, or inside of Python. I mean, there's all sorts of ways to just spin up, something like a web server. So, suddenly that number of, well, there's just Apache, or maybe there's just Apache and Nginx, suddenly the number grows to 10 to 5 to 20, 30 different ways of doing this. And all of them are going to, every customer of every single different product variation that does replicated things is going to tell you that their product is the important one, right? Yeah, it's a no-win situation. So distribution tries to be good at offering a variety of different packages, even ones that have functionality overlap. But that's a multiplier. But just in the sheer number of packages and availability of software, it gets to be maddening. Now, in a Windows world, for those who, because most of you are coming from a Windows world, it's, you say, well, gosh, Windows been doing this. No, Windows has not been doing this. Windows provides an operating system and the distribution of application software for them has primarily been outside of their venue. Okay, so Microsoft isn't out there, providing, Adobe Creative Suite as part of an install, and then they maintain patches to it. No. I mean, it's closed source software for one thing. So especially in a closed source world, you're dealing with the only person that can distribute a package. Now you're placing the ownership of making sure your software works across versions of the operating system upon the third party closed source software developer. And so they have to make sure that their products work across, work in Windows 10, 11. They may have to have separate versions depending on what changes happen, inside of those operating systems. So from a Windows perspective, Windows really doesn't understand anything of what I just said, okay? But in the Linux world, this was certainly the case, that a full managed Linux distribution, every product that was available, and it was lots, right? And you say, oh, you mean like it's 10 times what Windows provides? No. You say, well, it's 100 times what Windows provides. No. It's thousands of times. Okay, so it's at least 2 orders of magnitude the amount of managed application space. Okay, and that may be conservative, right? So someone say it's 3 orders of magnitude, I'd be like, yeah, I could see that, right? It's huge. So it's not something that Microsoft's really had to deal with, before. And I'm not saying that they should, being that they cater to the idea of third-party closed source kind of environments. I mean, that's that's the culture, of the system. That's just not the culture, inside of a Linux distribution where most of it is free and open source. So you can actually package everything up and compile it and build it and integrate it and test it and do that stuff on your own. You say, well, don't other companies want everyone to test their software? Maybe, but they will never, because they would rather have it be closed, and that forces that whole burden solely on them. And that's why a lot of times you see more problems in the commercial software world, or might not see, right? Because sometimes the problems exist, but there's not enough people actually actively looking at it or testing things because everything's closed. So you kind of usually have to wait, for the company to fall over, or something to catch fire or something really bad to happen, and then suddenly you can react to the situation. Just the difference between, the two models, a closed source operation model and a open source operational model. But the problem with the the free one is that management of packages. If you're trying to be in a corporate enterprise mode and you're trying to operate much like uh, commercial software combined with Microsoft, with its support and stability and all that, you're going to probably produce these managed distributions, like I said, with particular version levels of product not moving forward. Why not move forward? Again, all this segue was to answer that question. Why not move forward on all of your software packages? Let me give some extreme examples. So these are contrived, but let's say that I write a configuration management system, and as a basis of my configuration management system, all of your infrastructure as code is written as a set of XML. Okay, so you write all of your definitions in XML. So now you're loving it, you're using it, it's enterprise, it's stable, it's, in your Linux distributions, everybody in the world's using this. And so now you write thousands and thousands and thousands and thousands of lines of XML infrastructure as code to run this system, of yours. And, and it's custom to your environment and everything. Great. You're not necessarily distributing. I mean, you could, but, most of the time, the main thing is so you can run your business. And so you're doing good configuration management. The system is working. But let's say the developers say XML stinks, okay, which it kind of does in a way, right? And so they want to move to YAML or they want to move to JSON, either one, right? Let's say they move to YAML. They say we want to define all of our infrastructure as a code as YAML, and we're not going to support the burden or the baggage of the XML system. Now, developers don't necessarily care about your ability or inability to move along with them. They're making good decisions that make sense to them and not necessarily decisions that make good sense from a business cost perspective with regards to stability. So if they make that kind of a change and suddenly all of your infrastructure is code, which you have tens of thousands of lines of, and it runs your production shop and keeps it stable and everything, and suddenly in order to get fixes, you're forced to move to the next version, and the next version says everything has to be written in YAML. That's a huge barrier, right? And so basically now, if you're placing the burden of me having to make a lot of changes, and you say, well, okay, but it's worth it. Let's do it. But what if I multiplied that workload by 10,000 packages? So what, I know I'm talking in case of a worst case scenario, but what if I multiplied this kind of a burden out that far? Then what ends up happening is that people lose trust in the corporate viability of the platform because uh, it changes way too rapidly and in radical ways that impacts business. Okay, so it's like, why would I use that? Does that kind of make sense? Okay, so again, Windows people aren't going to understand because Windows as a base operating system doesn't do a whole lot. Okay, but if you've ever asked yourselves why certain pieces they do include, which arguably maybe they shouldn't, but they do. So, for example, something like IIS, their web server, which may come bundled as part of their operating system, it doesn't change much. And you say, well, it's arcane and it's archaic and, I hate it and everything. But the reason it doesn't change much is because in this case, Microsoft does own that, for right or wrong. They've chosen to own that piece or want to own that piece, and that's why it doesn't change much. It's not going to do any kind of radical changes because they know that of the impact that might have to their particular world. Much like what I was talking about, why you don't want a managed Linux distribution to just radically change a whole bunch of products underneath just so you can do major version jumps. It may sound cool, but the impact to business could be extreme. And you know, that's why these things exist. That's why they exist. This is why something like Red Hat Enterprise Linux, Alma Linux, Rocky Linux, all these things, OpenSUSE, well, not so much OpenSUSE, but SUSE Enterprise Linux. This is why these things exist, Oracle Linux. They exist to provide a corporate zone of stability. It's not that things don't progress or move forward, because they do version, right? So you do go from Red Hat Enterprise Linux 8 to Red Hat Enterprise Linux 9, and now soon Red Hat Enterprise Linux 10, for a lot of companies. And so you are going to see those kind of bumps, but they are radical. You are going to go through the testing processes, when you make those kind of changes. I will admit this with Windows, and generally speaking, you can roll the dice a little bit more with Windows on major version changes. Doesn't mean it's perfect though, right? We've already seen that. If you've been following anything for the past several years, from Windows 7 to 8 to 8.1 to 10 and 11, you know that there have been some struggles there. But also, it's quite could be that your package software, even from the Windows 7 days, may actually install and run acceptably, depending on what it is again, on a later version. And some of that's kind of true in the Linux world as well. So don't get me wrong. Like, I have one of my favorite games to play in Linux right now, on my home systems, is Unreal Tournament 2004. Yes, 2004. So something that came out really in 2003, right? As far as when it was released. And, so Unreal Tournament 2004. And I play that on my Linux system today, which is a tribute showing that, a complex game port. This is not Steam or Wine or anything like that. This is a direct port of the game using OpenGL, because that was the thing at the time. So we're talking about, early DirectX days, and OpenGL was still, kind of in a battle, with this new DirectX initiative. And so it dates back to those times. And OpenGL, of course, meant that it was portable. It could run under Windows or it could run under Linux. And that was just what they did way, way, way back when. But the fact that that software still runs video and audio and everything is a tribute to not just the makers of the game, but also to the ability to make old things run. And by the way, it's also 32-bit, right? So there's that aspect too. So when you hear about an OS saying, we're going to drop all 32-bit support, things like that kind of scare me, because it's like, that means things that I'm holding on to may not work anymore. Just like with the recent, an example of this that you may know, because I may be talking about things you don't know about, but things that you have heard about that you may think are interesting is when, for example, NVIDIA dropped 32-bit PhysX support from their driver for their new set of drivers that are out for the 50 series NVIDIA cards. That meant a lot of old games would seek to work or perform really well without PhysX controls. Now they've since open sourced of that, so they listen to the community, they listen to the problems that are happening out there. But But that just gives you an example of what happens so oftentimes, as things evolve, things do get dropped out of support. So it is just amazing to keep that support going on. But from a corporate perspective, we love the stability. We love keeping things moving on. We know it can't last forever, but we do expect to have, 5-year, or more runs out of a particular platform we choose. And so enterprise Linux makes really good sense, from that perspective. Okay. Now, in the development land, in the exciting land, of people that want the very latest always, because I just bought a peripheral and only came out 3 days ago, and in order for me to get support, I'm going to have to run the latest kernel versions. We're at least updating our kernels and our drivers, even in a relatively stable operating system, or we're moving to operating systems that version faster, like say twice a year, every 6 months, or we move to what we call a rolling distribution of Linux, which of course tries to stay up to date on all packages, all version levels within a matter of days. And so basically you get hundreds of changes a week on those systems, right? But with the risk that anything that you've invested configuration-wise might have to be totally redone to adapt to the version level changes that are being pushed out by your what we call your upstream or your actual original developer who's in charge of the project. So as they move forward, you may have to do rework in order to support that. All right. So hopefully I've laid the foundation. Next, the world is changing because of all the struggles for a distribution manufacturer, even on the enterprise level, to be able to manage it all. We're all trying to shirk work, and this is bad, but it's trendy. Where did this trend come from? The trend came from containers. Okay, so really the trend here came from the idea of containers. Some people might say VMs. No, it came from containers. So the first in container, we'll say Docker. Okay, so the Docker movement primarily. Okay, the idea of software maintained by the developer itself and then imaged, put into an image repository, which makes it easy for me to download and run it. And it contains all the batteries included. So inside of that world, it's got the ability to either pull down, we're either pulling down dependent images to use, or we're packaging everything that you need all in one space, and it all runs inside my containers. So containers, everyone says, well, the containers are efficient. Well, yes and no, right? Because if I'm packaging everything known to mankind into my container for safety purposes, for longevity, then there's a lot of repeat. So there's a lot of dependencies inside of any given image that are actually replicas of dependencies in other images, just at various version levels. Why? Because of this problem we've already talked about. Sometimes radical changes happen from version to version. APIs change. Configuration formats change, or what have you. So it sounds safe and it sounds easy. But people talk about containers and they're like, well, these are efficient. And it's like, no. So a container versus running a process is anything but efficient. Okay. So it's less efficient, but it does give you a lot of abstraction. It gives you that power, that flexibility, batteries included, the ability to have some lightweight network controls, over the top of your thing. So you don't have to worry about deploying software necessarily and figuring out your reverse proxy structure. You may be able to leverage like what a Docker environment might present to you to be able to handle most of those things. And you're happy, right? Because it gives you that ease, right? But you still have this waste, right? Where, and you still have to keep up, right? I mean, what's the answer to when there's a security problem with the image that you're running? You upgrade, right? Well, if you upgrade and replace that container, and you say, well, They take care of all the config and everything for you. Do they? In all cases, if it's some system that operates via an API, and then they radically change their API, or the way you have to call it or what have you, then that's going to have huge impact, and you're going to have to change and adjust. So you still inherit some of the problems that we're talking about with the change of version, and you definitely have that inside of containers. Now you can say, well, but I'll just always make sure, because this is the case. So in the container world, or in these image repositories, usually you'll say something like, if this is a problem, me updating my container, I'll say you can only update this container up to this version level, and no further, right? So you can do those kind of things, which is kind of nice. Okay, but what does that mean? That means I have to keep all these containers, and are the developers going back and backporting security fixes into those prior containers? Somebody's got to do it, right? If security is interesting. So you can see some of the problems. So some of the problems we haven't really escaped from, someone's got to be in control of doing that, or you just ignore it. And now everyone's got to always move forward, and you have to bite the bullet with regards to whatever changes that a developer is mandating of you at any given time. The only problem is that it's multiplicative. It's number of packages, number of versions, and number of developers behind all that pushing you forward. All that burden now placed on you, the corporation, to manage. And if people that are probably staffed, 1,000 times more than you are having trouble keeping up, you think you're going to keep up? You say, well, I'm not installing every package. I understand that. But you're probably leveraging a fairly good set, 100 or 1,000 packages or whatever that you actually use on a daily basis, or images or whatever containers, whatever that you're leveraging. Can you manage that? And I would argue that the world has decided that I want to be in the enterprise space and I want to play, but I want to put the cost burden of all that on the individual corporation. And I don't think it can actually sustain the weight of this. So it sounds fun. It answers the question, how's the distribution going to keep up with all this change? We'll push the burden of all that change onto our consumer, onto our customer. Not unlike the Windows world, by the way, right? Because Windows, with regards to software, that was certainly the case as well. It's just that oftentimes you're dealing with commercial software, which is kind of a black box. Does it have security problems? Does it not? Do we care? It's closed source, we don't care. And then we just wait for the fire to start. It's just unfortunately a lot of times the fire is starting my own backyard, so I'm the one that's getting damaged, by the fact that these things have security holes inside of them. The FOSS community, by porting all this FOSS software, because the nice part about FOSS software is it can be made available anywhere. So as FOSS becomes more of a thing, and it is a huge thing now inside of Windows, right? So all that packaging, we're like, gosh, Linux can do all these things Windows can't. That's no longer really the case, because most of that software now, because it's free and open source, has been ported over to Windows. And it makes sense, right? So it's like, okay, that's kind of the beauty of the whole open source model. So now we can take that ginormous library of free software that we had at our fingertips that was so awesome inside of Linux and move it over into the Windows world. But it doesn't change the problem that I just described, right? So you still have these issues, and probably more so in Windows, because it's not like you're using some kind of there's a little bit of this. So think about when Windows attempts to actually provide a managed distribution with free software. So we'll talk about WinGet and its predecessor that a lot of people use actually even today, and preference that Chocolatey. They'll use these repos of software, which contain commercial and non-commercial things, by the way, but closed and open things. But they'll use these things, and that's kind of supposed to give that essence of management. But I would argue they are not managed at all. Okay, so it's like a badly managed Linux enterprise distro. And you can prove this. You don't have, you can say, Chris, you're wrong. WinGet, Chocolatey, these are awesome. No, they're not. They're horrible. And they don't they do portray the problems that I'm describing. But as far as their management, it is far, if you thought there's a problem in enterprise Linux, multiply it by a lot. And that's what you have today with those systems inside of Windows. And that's why you have so much debate about what ones to use and whether WinGet's worthwhile. Because one day WinGet looks great, and then the next day the package selection is rife with problems, and you hate it and you want to get rid of it. And so you switch over to Chocolatey or something else, and you start using it, and it starts having problems. So you go back, and suddenly Microsoft or whoever is taking more interest in WinGet, and it's like, okay, this is not the stable universe that corporations like to see. Okay, so that's some of those problems. But where's Linux? So we talked a little bit on Windows. There was kind of a little segue there. But where's Linux heading? And I don't necessarily like this. But as enterprise distributions struggle with the ability to maintain a complete managed distribution and the tens of thousands of pieces of software that come along with it, if we start going back to trying to pull from upstream in some way using something like containers, and we don't use Docker, by the way, so that's old school in the Linux world, and I'll speak to that in just a second. But that concept of upstream delivery via some kind of container mechanism, something like that, which forces us just to keep rolling forward if we want any kind of fixes of any magnitude, but having to eat the cost of radical change to those pieces of software, which again, I would argue we don't have the staff to really do, right? But Linux is moving that direction. They're wanting to do that. So from my perspective, this is going to spell the end of big money enterprise Linux distributions. Why should I pay a big managed Linux distribution when they don't give me any value now? They're not doing the hard work. If they're not going to do the hard work and they're going to place that burden totally on me, I might as well just save my money, and you can use pretty much anything. Roll your own Linux. I don't care. Whatever you want to use, because all the packages are coming from upstream anyhow. The way that Linux does this today, because I mentioned it's not really done through the idea of container distribution. So I would call that a stopgap, so we see kind of a stopgap with that. And there are container worlds out there, don't get me wrong. So there is the idea of running, orchestrated container environments like Kubernetes or Docker Swarm or things of that nature. So you do have those kind of ideas out there, and you may have that in your corporate world. And you may lean on it, and that's fine. There's nothing wrong with that. But talking about just from the basis of the pure OS scenario, if we can take it out of that for just a second, so even going back to the operating system level, which still makes sense in my opinion, but maybe some people may say, nah, that's old too. That's going away. But if that still stays around, what's happening is the shift to something like Flatpaks. So there are competing technologies out there, but I'll tell you right now, I'm pretty sure that out of the ones that are competing, that Flatpak is probably going to be the winner. So the idea of the Flatpak is the idea of delivering an executable, all of its dependencies and everything. Does it sound familiar? And basically a container. So it's going to be containerized and safely run, and it can be controlled. So you can say, okay, this container can see my entire file system, or this container when it runs can only see this or this. It can only have access to these resources. So it's controlled. It's kind of like an app, on your phone where it tells you, you must give it permissions for all these things. So you can actually control, and you can actually take what's delivered to you by a particular upstream developer or whatever. They can deliver your package, and then you can override their default settings with regards to security, so that it can say, well, I don't know where you're getting your files from, so I'll make it to where my package can see files throughout your entire system. So maybe it's an editor or something, and you say, gosh, I don't want this editor touching anything except this files in this particular directory. You can override your Flatpak's security after the fact. So you can actually install a Flatpak, go in and change the security parameters after the fact, and further constrain it. So that's kind of nice. So that has those kind of features, but it's very much just like a container world, but at the OS level. And so I see a lot of movement in that direction. But my warning is this: uh, they're they're never efficient. Okay, hopefully I've proven that. So in other words, if I have 5 packages and they all need a particular version of a library, and those versions differ from one another, you're going to have that library, that particular version, because they're dependent upon it. Each one dependent upon a specific version that's different from each other. So you now have that DLL. Does this actually sound like any problem you've seen inside of Windows, by the way? Like, for example, with the amount of uh, VB. I can't remember all the different libraries out there, but it could be DirectX, could be, so you see a whole repetition of need to keep a whole lot of different version levels of the same style of DLL or library on your Windows host, and it gets messy, right? It's filling up your disk over time, and sometimes you end up with packages that are installed on your system you no longer use that may still be installed. And what a waste, using all that disk space because of all this, it's trying to handle and make sure they can, it can actually be run if it was ever called on to run. But it gets expensive, and over time, and as the platform gets older and older, this trash just tends to accumulate, right? Now, Flatpak helps a little bit with that, so there's a package manager, with Flatpak, so you can actually remove packages and, you can update packages and it tries to share. So like a Flatpak sees 2 packages that use the same version of a particular product. You're not going to get multiple copies. It's going to try to share those. But then as soon as they diverge, certainly at that point you will have replicate copies, so it'll try to merge where it can and it'll diverge where it has to. You have security, you have all these tools that you're used to, maybe in a cloud managed environment, but the emphasis is the entire burden of, the weight of the security and the maintenance and changes, testing, everything shifted and is now on the corporation. And I would argue that this isn't, uh, it's happening, like I said, it's happening in Windows, maybe not to the same extent, but it is. It's happening there, it's happening in Linux, and I would argue it's a bad thing, for businesses. Um, and, but, businesses say, hey, I've been managing my own apps for a long time, but I would argue that you're probably not updating those apps every day like you should be. And you're probably creating what I would say, so what ends up happening for everyone who's like raising their hands thinking success, I've moved to the new way of doing things, you probably have a lot of security vulnerabilities because you don't have the time. You don't have the time to keep up with it, test it, ensure it. Companies can't afford to be down hours a day because things are changing that rapidly. Uh, there's a lot of issues here, right? So even people that try to run these blue-green, or whatever kind of environments, they're staging production style environments, all it means is that their production is in a lot of risk potentially until that next staging is ready to be pushed out. And you can say, well, that's good and that's acceptable and we've done it. And it's like, yeah, but a lot of risk, right? And so we're putting a lot more of those security risks because of how big the problem has become. We're pushing that um, onto corporations where a lot of that risk was previously in the nature of the systems that they used. And those people who oftentimes were paid money for support, that was one of the benefits that you were getting from that, was those patches and updates in a non-intrusive, non-impact manner, emphasis. So now my XML doesn't magically change to YAML. You get my drift? Okay? So what the difference is? So I get those changes, I get those security fixes without dramatic impact to my operational stability. Anyway, bringing it up. What do you think? I think the new world is awful, and I'm glad I'm getting old because I'll be out of it, and I'll leave it up to you guys. And probably you're going to reinvent the wheel, and you're going to go back in many ways to the way things used to be. Today, you're laughing at me. You're going, you're not modern, and I'm laughing, going, this is going to kill you. I don't know, maybe AI is the answer. AI goes out and makes everything work. No, it won't. It'll have the same issues, right? Maybe even worse, right? But maybe we don't care anymore. There was a day when we didn't care so much about security and things falling apart and people hacking us to death. Are we heading that direction to where we just stop caring and the whole thing just becomes the wild, wild west of hackery, in computing land? That's a possibility too. Apathy could be the end result of all this. We'll have to see how it goes. What do you think?